All right, this will be a video showing some multiplication strategies. I had some students who talked to me specifically about having some issues, having some difficulty with just multiplication and with just division. So I plan on making a division video as well. But there's a few things I want to talk about for multiplication strategies. Let me go ahead and rewrite this. First thing I want to talk about is just what multiplication is. Multiplication is repeated addition. For example, if I say 2 plus 2, well, we know that equals 4. 2 plus 2 plus 2, well, that's going to equal 6. 2 plus 2 plus 2 plus 2 equals 8. 2 plus 2 plus 2 plus 2 plus 2 equals 10. We could probably figure that out. We could probably just use our fingers. 1, 2, that's 2, plus 2 more makes 4. Add 2 more, 5, 6, 7, 8, 9, 10, right? And we came up with, you know what, instead of writing this out like this, let's make it a little easier, and let's just write 2 times 2 equals 4. And I'm not gonna use this x for multiplication anymore. So we have 2 times 2. Oh, and this one's actually 3, isn't it? Excuse me. 2 times 3 equals 6. Here we have 2 times 4 equals 8. And I'll use parentheses on this one. 2 times 5 equals 10. Okay. But with twos, you're just doubling that number. You double that number, double that number, double that number. Twos are pretty easy. Twos are pretty quick, right? I would doubt that anybody has any issues with their twos, but I do recognize there's probably some issues when we get around to things like 7 times 8. So like if I said 7 times 8, well, now we run into some issues. So this is one I want to solve. And I'm going to show you a few different ways we can do this. Okay. If you know what, let's see, one way would just be to list multiples. Okay, so on this, if we're going to list multiples, that means we're going to start here and we're going to write 7. And then the next one is whatever 2 7s would be. So that'd be 7 times 2. So this is times 1. Here's times 2. 7 times 2 would be 14. And if you haven't memorized that, you can use your fingers and count it. That's 7, 8, 9, 10, 11, 12, 13, 14. 14. Same thing, times 3. You just add 7 to this. So this is plus 7, we'll be at 21. And you might not do it as fast as me, but I think that you shouldn't have any trouble just starting at 21 and going 22, 23, 24, 25, 26, 27, 28. There's another 7, 28. So this was times 4. And we're just going to keep going. So times 5, times 6, times 7. And here's our target is times 8. So 28. 5s, we probably know our pattern for 5s. So instead of doing 7 times 5, I'm thinking 5 times 7. So 5, 10, 15, 20, 25, 30, 35. Because we can probably all count by 5s. Now for the 6, we're going to add 7 to this. If I add 7 to 35, here's what I do. Instead of adding 7, I add 5, and then I add 2. Because I know that 35 plus 5 is 40, plus 2 more makes 42. I know that 42 plus 8 would be 50, so if I'm doing plus 7 instead, it's 1 less than that. So plus 7, plus 7, plus 7. So if I add 1 to 49, I'd be at 50. I have 6 more to go, so that's going to be 56. So I can find out that that equals 56. Okay. I realize that here in 7th, here in the 8th grade, you may not have memorized this number. Okay, or maybe you have. And if you have, you probably don't need to watch this video. Okay. But if you don't have this memorized, well, we got to figure out a way that we can solve it. And one way we can do that is to list these multiples. Okay. The next way is we're going to say break it apart. So this one will probably look like it's a little more work, but it might bring the numbers down a little bit so it's easier to understand. Not sure, but let's find out. So if I'm going to do, I don't want to do 7 times 8 again. I want to do a different one. So let's say about 9 times 6. And maybe you remember your 9s trick. You take your hands, put your 6th finger down. Oops, different picture here. Put your 6th finger down, and I know it's 54. Okay, so maybe you know your 9s trick, because that's my 1, 2, 3, 4, 5, 6th finger I'm going to put down. And then I see 54. But I want to show you another thing we can do here. Maybe I know what 9 times 5 is. So I'm going to break this 6 into 5 and 1. So instead of 9 times 6, what I'm going to do is 9 times 5 and 9 times 1. Okay, so this is actually, break it apart, and I'm going to rewrite this as the distributive property. So I know that 9 times 5, I can count by 5s 9 times. I'm going to get 45. It's 5, 10, 15, 20, 25, 30, 35, 40, 45. So right here, this part is 45. And then 9 times 1 is 9. So I can start at 45 and then add 9 more, which is going to take me, well, if I add 5 of this, because I'm kind of breaking this into 5 and 4. Because then 5 and 45 makes 50, plus 4 more makes our 54. Okay, so another thing I could have done, say instead of 9 times 6, maybe I want to break this into 5 and 4. Okay, and then I'm going to multiply those by 6. I know 6 times 5 is 30. And then if I don't know what 6 times 4 is, well, I could list multiples. I could list multiples of 4, list multiples of 6. So let's see, 6 times 4. Let's see how we can do that. I know what 6 times 2 is, and this will be whatever that is, times 2. I broke 4 into 2 and 2. So I know 6 times 2 is 12, and then we'll do 12 times 2. In order to do 12 times 2, I might break this into 10 and 2. I know that 2 times 2 makes 4. I know that 2 times 10 makes 20. So that's 24. So then 4 times 6 was 24. And when I add these together, I should get 54 again. Okay, so that's breaking those numbers apart and maybe doing smaller versions of them. I will do another one like that because I think that was very confusing probably. So let's go back to the, let's go to 8s. How about 8 times 6? So I know what 8 times 5 is, because 5s are easy. So I'm going to rewrite this as 8 times 5 plus 8 times 1. Because that's 6. This is a total of 6. Okay? So, like, essentially what this is this is 8 plus 8 plus 8 plus 8 plus 8 plus 8. That's 1, 2, 3, 4, 5, 6. But what I'm going to do is I'm going to say, well, I know what 8 times 5 is. 8 times 5 is 40. So now I just need to add 8 to that. And that should be 48. So right here I have 40 plus 8, 48. So this is another one where we're just breaking it apart. We're doing it in pieces. Okay. So that's another strategy. Okay. Another way is going to involve larger numbers. And we're going to break them apart, basically. Say I do large numbers and zeros. So, for example, if I say 11 times 17, okay, what I'm going to do is I'm going to break this one apart into 10 and 1. I'm going to break this one into 10 and 7. And I'm going to multiply these together. And you've probably seen this type of model in 3rd or 4th grade where they broke 10 and 1 into 2 different boxes. So there's your box for 10 and 1. And your box for 1 should be pretty small because it's not even nearly as big as 10, right? And then we're going to have another one that's 10 and 7. And this box should be a little bit bigger, but not quite as big as this 10, right? 10 times 10, the trick with zeros is to cross them off, do whatever that digit is times that digit. 1 times 1 is 1. And then the amount of zeros that we crossed off, 1, 2, we're just going to put those here. 2 zeros. So that was that. 7 times 1 is 7, and I have 1 0 in that problem, so that's 70. 1 times 1 is 1 with 1 0, makes us have 10. 7 times 1 is 7. There's no zeros on 7 and 1. Okay, so then we have 100, 70, 10, and 7, and we need to add these up. 7, 8, 187. So this is larger numbers. I really like this method, but I want to show you another thing we could have done here. Maybe would have made it a little easier. Is break this 11 into 10 and 1. So now I'm doing 17 times 10 plus 17 times 1. 17 times 10, we're going to do our zeros trick. We just cross this 0 off. 17 times 1 is 17, and then we put our 0 on it. Okay, plus 17 times 1 is just 17. And we're just going to add these together, 170 and 17. 7 plus 0 is 7. 7 plus 1 is 8. 1 plus nothing is 1. We get our 187 again. Let's see, maybe another way. I'm really kind of just making these up right now. Let's see, number 4. We'll do the standard algorithm. This is where you write 17 times 11 like this. I'm going to make it 17 times 17 instead, so it's different than the last one. And actually, I'm going to make it 217 times 17, which means we have 217 17s, where we'd be like 17 plus 17 plus 17 plus 17 plus 17. We'd have to do this 217 times. And that doesn't really, I mean, it's going to take years, right? And probably get it wrong, because even I would get that wrong. Lots of room for error. Or we could do 217 plus 217 plus 217. We'll do this 17 times. And again, that's like just asking for mistakes. So what we do here is we break this down into, well, I'm doing 217 times 7, and I'm doing 217 times 10. And that's what these two numbers are going to be. It's the exact same as what we just did in that last problem. It's the exact same as another thing we could have done is 200 times 10 and 200 times 7, which crosses this off. We did the 10 and the 7. We have 10 times, I'll put it in that, 10 times 10 and 10 times 7, which crosses this one off. And we have 7 times 10 and 7 times 7. So 7 times 10, 7 times 7. And this is the same thing if we were to break that into an area model. So we'd have 200, 10, and 7. And we'd have 10 and 7, like that. It's the same thing. I just expanded them out like this. But you were probably taught mostly using the standard algorithm, using 217 times 17. But I wanted to point out that this method that your teachers showed you, this method that your parents probably know how to do, and they're probably really good at it, is really no different than what we have over here. Okay, we're doing 217 times 7. We're doing 217 times 10. And those same numbers would be right here. If you added all three of these numbers up over here on this table, on this area model, well, that's going to be what 217 times 10 is. And this one is going to be 217 times 7. And those two numbers are going to be the two numbers that we add up here. So 7 times 7. I think we had that on the one earlier. what we did was we listed multiples on 7 times 7. So I want to do it a little differently this time. I want to break this into 5 and 2. I know 7 times 5 is 35. I know 7 times 2 is 14. So let's see, what's 35 plus 14? 5 plus 4 is 9. 3 plus 1 is 4. So here's our 49. So I put my 9 here because it makes 9 ones. And this 4 tens, is going to regroup here. We'll have to remember to add that 4 tens in just a moment. 7 times 1 10 is how many tens? Well, that'd be 7 tens. But remember, we have 4 more tens to add to that. So that'll make us have 11 tens. And if I have 11 tens, okay, it's actually 110. So I have this 100. I need to regroup and remember to add in a moment. 2 times 7, or 200 times 7 is 1,400, right? But I have another 100, so that's going to be 1,500. And if we're going to add 1,500 to 19, it's going to look like this. 2 times 7 is 14, plus 1 makes 15. Now, why do we put this 0 here? Why do we do this? Well, this number is not the number 1. It looks like the number 1. You can argue, I think it's the number 1. Look at it. It's the number 1. But it's not. This is not the number 1. It's the number 10. That number 10 is right here. Okay, this is a tens place. It's next to a 7 that's in the ones. This is 7 ones. This is 10. So 7 times 10 is 70. That's why that 0 goes there. It doesn't just go there because our teacher told us to put it there. Okay, that's 7 times 10 is 70. That's why that's there. It's 70. Now we're doing 10 times 10. Well, that's 100. Okay, 1 times 1, well, it's 100. We put our 1 here, but that's in the hundreds place in this row. That's 170 now. Now we need to do 200. So that's 200 times 10. Remember, it crosses the zeros off. That's 2 with 3 zeros. Well, that's 2,000. But 2 times 1 is just a 2. But it is. Notice it's in the thousands place. Okay. So then we go ahead and add what we got for 217 times 7, which, by the way, goes right here. And then our 217 times 10 was going to go right here. We're going to add those two things together. That's 9, 8, 6, 3. 9 plus 0 is 9. 1 plus 7 is 8. 5 plus 1 is 6. And 1 plus 2 is 3. It's 3,689. Now, if you have a problem like this, my next step for you would be, and I'm encouraging this, okay? I'm your math teacher. You've probably been told, don't use a calculator. You can open up your calculator, hold it up, and check it. 217 times 17. 3,689. I'm going to be honest, I've made mistakes. I've probably made mistakes in your mountain math videos, in your book videos, okay? And maybe I didn't even catch them sometimes. Hopefully, if I did make a mistake, I've caught it. I know for a fact that I've caught several mistakes, and I haven't edited any of my videos. So those mistakes are in my videos, okay? But, I mean, we make mistakes. We're supposed to make mistakes. We then use those mistakes and we learn from them. Okay, so if I got this wrong, I would have to go back and find where I made my mistake. Okay, I wouldn't just say, oh, whoops, it was a 9. It's wrong now, but pretend I had a 9. Let's just say that was a 9 before. And I was like, oh, that's the wrong answer. It's actually supposed to be 89. The wrong thing to do would be, I'm just going to change this to an 8. No, I'm going to find out. 7 plus 1 actually is only 8. I accidentally added 7 plus 1 wrong. That calculator is a tool for you to help yourself learn, okay? Because I'm not always right next to you to tell you, hey, that one's actually not wrong. Yeah, just check that little one right there, please. Use your calculator. Your Chromebooks have calculators, okay? Check your work. They're really helpful, and they really help you find those mistakes. If you're doing 7 times 7, and you try one of these strategies, you try and break it into 7 times 5 plus 7 times 2, and you do it this way, check it. Do 7 times 7 on your calculator. Pull your phone out. Type it into your phone calculator. I have no problem with that whatsoever. Okay. But I do need to see your work. So like if you had to do 17 times 217, I would expect to see this. Or maybe this if you chose to do it this way. Okay. That's just what I would expect to see on your paper. I wouldn't expect to just see this product, this answer. Hopefully that helped. The first thing we did was listing multiples. Unfortunately, it doesn't work for problems like this or like this because we have to add that number that many times. But it's repeated addition, but when we get really big numbers like this, it doesn't really work anymore. We can break it apart. We can use the distributive property, which is what we did right here. We broke this 7 times 7 into 7 times 5 and 7 times 2. We broke that 7 apart. Maybe you don't memorize your 7s, but I bet you memorize your 5s, and I bet you memorize your 2s. And now all you have to do is add those two things together. Okay? Or if you're doing your 9s, if you're doing 7 times 9, I'd break this 9. I'd probably break it into 5 and 4 myself if I was trying this strategy. But maybe you don't remember your 4s. So maybe it's 5 and 2 and 2. 7 times 5 is 35. 7 times 2 is 14. 7 times 2 is 14, and you would add all three of these together. Okay? You can do that. That's allowed. Another thing you could do, and now I'm just thinking of other ways to do it. I know what 7 times 10 is. 7 times 10, well, that's 70. So I just, instead of 7 times 10, I have one fewer 7. So I need to subtract 7, and I'll get 63. Okay? That's just another way. There's millions of ways to do this. Unfortunately, if you're a fully remote student, you're not in class to see all of these strategies. Okay? Hopefully this video helps you a little bit, especially if you've been having issues with this. This third method was larger numbers and zeros. So that's where we take these zeros off. I know that 200 times 10 is 2. 2 times 1 was 2, and then there's 3 zeros. So that's 2,000. Okay, take those zeros off. Okay, those large numbers, they're not different than what we've been doing. You're just moving the zeros around. You get rid of them, and then you're putting them back on. Then the fourth method is really what probably most of us do, especially if our parents are helping us on our homework. Parents are probably doing it this way too. That's how I was taught in school. It's how your parents were taught in school. And honestly, it's probably how you were taught in school too. And it's a way to do it, and it works, okay? But the reasons it works is because, I don't know, it's just a strategy. I mean, you're multiplying 217 times 7. You're multiplying 217 times 10. It's the same thing as what we did over here. It just looks a little different. That's all. So, I don't know. Hopefully it helps. Please always ask if there's any questions, okay? I only had a couple students tell me they were having trouble with multiplication. I know there's probably more than just a couple students who are having trouble with multiplication. So please, please, please always ask me questions.